Project 3.4.1, SAR ADC Overview and Clock by Atticus Tiplady. The purpose of this project is to create a general overview and successfully build a clock for the successive approximation register analog to digital converter, also known as the SAR ADC, using concepts found in earlier projects and providing a mapping for the rest of the project to follow. The successive approximation register analog to digital converter, as stated in the name, is a type of ADC that converts an analog signal into a digital output using a binary search algorithm. One fundamental recurring idea that is the groundwork for how this entire three-part project runs has to deal with something referred to as successive approximation. Successive approximation is a binary search algorithm commonly used that is key in converting the input of analog signals into a digital value efficiently. The ADC is initialized with the most significant bit by setting it to 1 and zeroing the rest. The code or desired value is then fed into an R2R DAC, which retrieves an analog equivalent to its digital input, initially referred to as 1/2 Vref, and provides it to the comparator, which values that sample input voltage. If the analog voltage provided exceeds Vin, then the comparator forces the circuit to reset the bit. Otherwise, the bit is left as 1. This process will repeat continuously until the least significant bit is determined, providing an accurate digital representation of the input signal. The resulting chain is the digital approximated output of the sampled input voltage. The clock, in theory, is also quite simple as it builds off of the concepts learned in previous projects, with one key difference, that being the incorporation of the hex inverter chip acting as NOT gates within the circuit in comparison to the 555 used in projects such as the Chump. Within this circuit, as a result of the circuit only being built with NOT gates whose main priority is to invert all incoming signals, not caring about the specific timing delay, the one small circuit has the ability to yield a period of 103 µs, resulting in a clock frequency that is close to 10 kilohertz. This is why the LED appears not to flash, as it is flashing too fast for the human eye. The circuit works as the two resistors that are incorporated on either side of the NOT chips form a bias in the ICs, making them function as a linear amplifier. In addition, the two capacitors cross-couple the inputs and outputs of both gates, creating an astable circuit whose outputs is used to drive the SAR ADC. On the top right, it says that each column is approximately 10.4 µs, and since one period spans 10 of these columns and is slightly shorter, the oscilloscope backs up the circuit, proving that it is flashing at 103 µs. Thank you for taking the time to watch my video on the SAR ADC clock and overview.